Good afternoon, everyone. Yeah. Do I need a mic?
Yes.
Okay. I am Abubakar Siddiq Ango. Okay. I am Abubakar Siddiq Ango. I work as a support engineer with GitLab. This presentation is currently available on this link in case you want to pull it down. Now, okay, like I said, I'm Abubakar Siddiq Ango. I'm based in Bauchi State, Nigeria. I work with GitLab. I'm also an organizer with GDG Bauchi and DigitalOcean Bauchi. You can find me on Circuit247 and Abubakar Ango, Abu Ango. Now, oh, sorry, I didn't introduce my. Oh. The topic I'll be speaking about is managing your cloud infrastructure using CI/CD with Terraform and Ansible. Now, automation. We all love to automate anything we do. A number of us will have deployed servers where you have like 10 machines to install Linux or Ubuntu or Debian or Red Hat on. You have to move from one system to the other to do your deployment, install the operating system, install all the services and applications that you require. It can be a very tasky thing, very mundane, and you spend a lot of time doing all these things. And life generally, we want to automate everything. No one wants to go through the stress of having to do the same thing over and over again. For example, you can, one day, we'll get to a place where you will just say, okay, Google, deploy a server for me with Apache, MySQL, and so on. You can say, okay. After some seconds, done. You can access it on this IP address. We are getting there. Since we can use chatbots now on Slack, we can use, and several other things. We can create issues, we can initiate pull requests and merge requests. Nothing is impossible. Now, why do we need automation? Standards, best practices. For something to be automated, it means it has gone through some level of revisions, some level of trial and error for it to be perfected, to now be released that, okay, let's make this thing automatic. Best practices and consistency. Every time you run it, you get the same result. So there is no, oh, it works today, it doesn't work tomorrow. And efficiency. For you to have automated it, it means you've tried everything possible, you've modified it, you've improved it, you've refactored it to make it work perfectly for you. Now, DevOps enables us to do lots of automation, and DevOps is beyond just the tools. It's the way we work, the procedures, the platform, and everything we use, from our source control to CI, to artifacts management, to deployment, testing, and so on and so forth. DevOps has enabled us to make things easier for us and be more productive. Now, from just DevOps, DevOps allows you to deploy services, manage your configurations, and so on, but it has moved to another new level. We have infrastructure as a service, we have platform as a service, software as a service, and so on and so forth. Now we have infrastructure as code, where instead of every time, the first speaker was talking about, someone will just come, the guru of the company, deploy something off head, no documentation, nothing, and he will just go. The next time he leaves the company, you have to be looking for him up and down. What is the password? What did you set here? And so on and so forth. But with infrastructure as code, it allows people to collaborate to build infrastructure. You can test them before actually deploying the infrastructure. You can version it using version control. And you can document the state of your infrastructure. You can know how your infrastructure is at a particular point in time. And you can even revert. We did something wrong. Well, let us take our infrastructure back to the way it is. More like we do with code. Now, what are the common use cases of infrastructure as a service? Versioned deployment. Onboarding new staff. You are new to a company. They give you a new system. Or if you're a DevOps engineer, they provide you with some cloud resources to use. And you need to bring it to a state that is acceptable to the company. Do you have to now start, okay, apt-get, install Apache to install this one, okay, configure it, my own is not working like this, my own is not working, or some SDKs. But with infrastructure as code now, you can have a template already existing. All you just need to do is run a single command, and you have whatever resources you need at the state that is acceptable to the company. Rapid disaster recovery. When something goes wrong on the server, something is misbehaving or anything, instead of wasting time to have to now, let's diagnose and so on and so forth, and you're having downtime, you can simply just delete that one, run the code again. In a couple of seconds, your infrastructure is exactly how it was. Customer support. Now, in my role at GitLab, I do support. You see instances where a customer will come, I'm running Red Hat Linux, this version, and the software is not working on that version. Do you have to start looking for, where will I test this, where will I test that? With infrastructure as code, with a few lines of code, you can have any type of system or instance, either on AWS, Google Cloud Platform, immediately. And you can test whatever you want to test and take it down. The easiest way to use all this infrastructure free of charge myself, just like I was saying earlier, is you spin up an instance, you finish testing, you take it down. I've once tested 120 gig of RAM on GCP. 2 minutes, I'm done, I shut it down. It doesn't have to incur, I don't have to incur cost. Now, cost control in an organization, by the time developers start spinning instances and forget about it, for example, you are running Kubernetes. You now have like 5 nodes, each running 16 gig of RAM. That's a lot of money. So the organization can control cost by knowing what are their developers or their staff running on any of the platforms. Quality assurance. And now, infrastructure as code is now much more easier with Ansible and Terraform. Now, both Ansible does configuration management. You want to know what services are installed on what server. You are managing a data center. You want to know, okay, on my web servers, I have Nginx running here, I have Apache running here, I have HA proxy running on this one for load balancing, I have database running here, and so on and so forth. That's configuration management. Ansible does that very well. But it has evolved now from just configuration management to orchestrating instances. It now has modules that you can use to deploy droplets. You can manage Kubernetes and so on. But Terraform, on the other hand, is best suited for deploying instances, either on AWS, GCP, and so on. It has even gone from servers to, if you use Cloudflare, you want to add an area code on one of your domain, you can do it from Terraform. Now, Ansible, like I said earlier, it's used for mainly for configuration management. And it helps you to manage mutable infrastructure. The last speaker mentioned that mutable is where what you've deployed can change. You install Apache, a particular version, then you make changes to your configuration and redeploy it again. It will bring it to the latest version. Now, it's flexible and stateless. Stateless in the sense that it doesn't maintain, okay, this is how the infrastructure is at this particular time. Okay, and this is what I need to change. All it just does is, okay, I need Apache 2 on this, and it will just execute it, regardless of what is already on the server. Now, it's also agentless. You don't have to have a client running on the host you are managing. It uses SSH to connect to any of the hosts. You provide the key, the private key, and it attempts to connect it. Once it connects, it can run whatever it wants to run. Ansible is mainly composed of your host, of course, the servers you want to manage. Playbooks. Playbooks are your configuration that you've already arranged in YAML files that you can now execute to run on the host. Now, Ansible also allows people to create more like a marketplace where people can create very complex infrastructure, then upload it online for people to reuse. You don't have to write your own all over again, and it is accessible at galaxy.ansible.com. That's Ansible Galaxy. Now, Ansible also has modules for different platforms, like DigitalOcean. If you want to create droplets, you want to add SSH key, you want to create a domain, there's a module for that. Almost all cloud providers have their own modules that you can use with Ansible. Now, this is an example of Ansible's configuration. The one on the left here, I'm trying to create a droplet. And I want to bring it to a state of presence. That means it should be existing. Now, this is my API token. I want it to be 2 gig of RAM. I want it in Amsterdam, AMS2, the normal regions of DigitalOcean. And this is the image I want to use, Fedora 19, x64. Then it should wait for 500 seconds before so that it will allow it to boot. Now, this is provisioning a droplet. While this one here is installing, configuring the server, I want HTTPD installed, that's Apache server, and it should be installed, the latest version should be installed. And this template of configuration should be applied to it, should be written to it. And here, it should make sure that it is always started. This is an example of the configuration for Ansible, and once you have this written in your configuration file, all you need to do is to run Ansible playbook, specify the name of the file where you stored this, and your droplet will be deployed. I will demo one for you now. Okay, now I will provision a droplet on DigitalOcean and install a web server on it.
Screencast.
Oh, forgot. And I saw you do it earlier.
Let's go to file.
File, okay. New screen recording. Okay. Start, right?
Yeah, we go.
Okay. It's okay, right? Ah. Now, this is an example of an Ansible configuration file. Now, what I'm trying to do here is I'm trying to execute a task. And what's the task? It's a DigitalOcean task. I'm calling the DigitalOcean module here. And I want the state of this, what it will do here to be present. What am I trying to do? I'm trying to add an SSH key to DigitalOcean so that any instance I create will be able to use the SSH key. So I'm now using this command here to say, look up in my file system for this particular public key. That way, part of today's theme is security. You don't have to pick your public key and paste it in the document. You can simply look it up. And also, my API, DigitalOcean API token is already in my environment variables. I will call it here so that it will be applied to the configuration. The next thing is to register this name that I have here so that I can reuse it later. Now, the next configuration is a droplet. I want a droplet with the name, my username, with this API token, 2 gig of RAM. It should be in Amsterdam, since it's closer to us, and it should have this image, Ubuntu 16.04 x64. And it should use the key the SSH key that I've specified earlier. Then, once the droplet has been created, it should retrieve for me the IP address, because normally if you want to use Ansible, you have to specify all the IP addresses of the host you want to manage. But since this is dynamic, I'm provisioning the server, I don't have the IP address yet, I have to wait for some time for the droplets to be created, then I retrieve the IP address. Now, once I've retrieved the IP address, I can display it here so that, okay, in your the output, you know the IP address that has been generated if you don't want to go into DigitalOcean. Now, the next stage is to configure the server. At first, I disabled it to gather facts. In Ansible, gathering facts is learning about the host, the operating system, the distribution. Every information it needs to know about the host is done at this stage of gathering facts. Now, so I'm asking it not to gather facts at this point. It should still wait and make sure I can SSH to the instance before it does anything. Now, once it's done, I need to install a couple of things that Ansible needs to use. So I'm running normal Linux commands here, apt-get install PHP, because Ansible is built with Python. Sorry, I said PHP, Python. Now, and it should run it as root, become user root, become method sudo. So everything it's doing here should do it at root level. Now, then here, after it has done all these things it wants to do, then you can gather facts. So the problem you might have in the beginning when you gather facts at first is it might not be able to reach the server because the server is not ready. It might take some time before it's provisioned. So, but here, you're not telling it to, okay, gather all the facts, the IP address, the distribution, the operating system version, whether, if you're using Ubuntu, whether it's Xenial or Trusty or whichever one. Then, the next thing is I want to run a role. A role is a group of tasks that you want to execute, grouped together. Now, here, the role I want to run is to install Apache. So someone has already packaged, in programming, reusability is very important. You don't have to reinvent the wheel. Someone has already written all the different tasks for executing, for installing Apache. So I installed this using Ansible Galaxy. I will show you how to do that. And specified it here that, okay, I want these roles to be installed. And all this will do is it will update Cage, the repositories, install Apache 2, and so on, and enable all the necessary things it needs to enable. Now, from this stage, the next thing is in command line. It's legible, right? Now, this is an example of Ansible command. I'm using Ansible Playbook because I'm not running a single task. If you're running a single task to the host, you just specify Ansible, the host you are executing it to, and the task you want to execute. Maybe you want to ping the server or something, then you specify. But here, what I'm saying is, the file I just showed you is saved to do.yml. That is a YAML file. Then I'm using this Python library for SSH, Paramiko, and I'm sending this environment variable, to the script. That's my DO token. This is already saved in my Linux bash RC. So now, once I execute this now, it will start executing every stage of my configuration. The first one here is, I specified it as localhost. Since I don't have a host yet, I have to create the host on DigitalOcean. Then, the first stage here is, this DigitalOcean is where I specified my SSH key. It has created the SSH key. Now it's creating the instance. The instance can take some time. The normal time DigitalOcean says is it 50 seconds or 55 seconds? So it will take a while to generate it. Now, while this is running, now let me show you an example of a more complex. I have all these scripts on GitLab, so I will share it with you so that you can have access to all of them and review them later. Now, this is an example of a configuration to deploy an HA, high availability web server online. So this script will deploy 2 droplets on DigitalOcean and a load balancer. Are we getting it? Now, the first stage, just like the other one, is to add my SSH key, of course. But here, I'm creating variables. This section, we have vars, variables. So the first variable is my SSH public key. Now, look it up from my system. I will not paste it for security reasons. Then the DO token, I'll be passing it through the Ansible playbook command I'm running. So you pick it up from there. Now, my web droplets, I want the first one to be named web-02. It should be 2 gig, based in Amsterdam. It should use this image. Backup should be enabled. And this is important, unique _name. DigitalOcean allows you to use the same name for several droplets. So if you execute, since Ansible doesn't maintain the states of your deployment, anytime you run your playbook completely and you run it again, a new set of droplets will be created. But when you specify unique name, it will check, okay, the name already exists. Then instead, it will just retrieve the details of it and continue the rest of the execution. But if you don't specify unique name and say it, set it to yes, it will create a new set of servers for you. Between yesterday and today, when I was doing testing and so on, only God knows how many instances I created, and I was just deleting after I created, before I would rack up plenty money. Now, the next one is the second server, the same web server, AMS2, that's Amsterdam, 2 gig of RAM. Then here, all here, I'm specifying my variables. Then the next thing are the tasks I need to be executed. Enable my SSH keys, add my SSH keys to DigitalOcean. Then the next one is make sure my droplet exists. Now I'm going to use a loop here, since I am creating 2 droplets. Now, run this task for me with these items, web droplets. And I've already specified them here as an array, web droplets. So it will iterate over each one of them and make sure they exist. Now, the next one is I need an instance for load balancing to install HA proxy on it. So I'll create it like a normal instance because Ansible doesn't currently support creating load balancers from on DigitalOcean. Now, once it's done creating it, it should now add each of my instance IP address to the list of my hosts. That's the list where Ansible can retrieve, okay, which servers am I going to work on? Now, once it retrieves all of them, then you can now start provisioning the instances. The first one, which are the web droplets, that means the one that will be serving the content. Okay, install all the dependencies first, then gather facts here. That means you should learn about all the instances I've created. Now, the first one, look up these rows, Apache and PHP 7. So each of my server should have Apache installed and PHP 7. So I'm installing this role from Ansible Galaxy because I don't have to go through the process of having to configure them again. And for it to have been published online, that means the person has checked it, he has tested and so on, and it's working fine. So now, and once you are done, we have pre-tasks and post-tasks. Tasks that should be executed before the main task and the ones that can be executed after. Here, I discovered that while it's executing and it installed PHP, my libphp mod for integrating Apache with PHP was not installed. So I installed it after all those ones are done. Now, instead of me having to upload my content, I have my content on Git. So what you should do is you should pull the website content that I want hosted on the server, each of those servers, pull it from Git onto those servers. Now, once it's done with all of that, it should now set up my H8 droplet and install HA proxy on it. The installing dependencies, gathering facts. Then it should use this role. Role is a set of tasks, but someone has built this one, and I'm reusing it here. And the backend servers, because Ansible allows you to create variables, and I've registered this. The other time, I was adding all of my instances to my host list. So here, I'm calling them back. That's host vars. The first one is web01. On this port, ETH0, IP gets the IP address and sets it as one of the backend servers for my proxy, load balancer. Get the second one and add it to the list of my backend servers. So once you execute this, you will have 3 DO instances, 2 serving as web servers and 1 as the load balancer. Are we getting this place? Any question? I have all this on Git. I will share the Git repository so that you can go through them subsequently. Now let me check this. It has run quite a lot of things and it's done. So now if I go to, on my local host, that is before I created my droplet instance, it ran 6 tasks successfully, and it ran 18 tasks on my instance. That's the droplet. If I go to DigitalOcean now, here, wow. Let me reload. This is our instance, already provisioned with Apache running. So if I copy this guy now, copy, and I paste here, I will have Apache running. And if I do /web, let me see, where did it Git? Oh, this is for the HA proxy. It's just, this is for the high availability one. It just installed Apache, it did not deploy anything to it. Do we have any questions, please? Now, the next one is, we can see that Ansible didn't just manage configuration, it deployed the infrastructure, right? Now, between orchestrators and provisioners now, their roles now bleed into each other. But Ansible is best suited for configuration management. It can provision servers, it can do a lot of things, but it works best for configuration management. While Terraform, on the other hand, works best. They don't even attempt to do a lot of provisioning. They work best for creating infrastructures, virtual infrastructure. And in contrast with Ansible, Ansible is procedural. From top to bottom, it goes that way. But Terraform is declarative. You can have files scattered anywhere, name them anywhere in your directory. Once you do Terraform apply or Terraform plan, it will look up all of them, match them together to execute. It's just like you declaring functions and variables in different files. You don't have to tell it this is where they are. As long as they are in that folder, it will execute them. Now, it's mainly useful for infrastructure orchestration. Deploy your servers. You can even deploy a very complex deployment, a whole data center using Terraform. Now, it's immutable. With Ansible, it's mutable. That means the configuration can change. The services installed on your servers can change. But with Terraform, if you just change the name, if you change some of the features of your instances, it will delete that one and deploy another one. It will even show you when you do plan, Terraform plan. Okay, this is what I will do. I will delete this, I will add this, I will change this, and so on and so forth. Now, it has providers and provisioners as plugins. DigitalOcean, AWS, GCP, Cloudflare. You can provision a server, add a domain to it, and do a lot of things just within Terraform. And it's also client only. Just like Ansible, you don't have to install anything on the client. Now, this is an example of Terraform's code. Now, you declare the resource that you want. This is the image I want, this is the name, I want it in this region. And I want this size. Now, a typical use case. Bauchi, where I'm from, you guys are very lucky in Lagos here. Internet is hell. Now imagine in my role at GitLab, I have to support customers, and I work a lot with Docker. Okay, there was a time a customer was having problem with TeamCity CI tool. I've never used TeamCity before, and for you to download TeamCity, it's almost a gig. You have to download it, you have to download the build agent, and you have to set up the version of GitLab server that is using. For me to download all these things, man, I can consume like 5 gig. And maybe you download network error or something, you have to re-download again. Are we getting it? So what I typically do is, I have an instance with Terraform set up online with like 8 gig or 16 gig, and I can increase it as needs arises. So anytime I need to do anything Docker, just SSH into the instance and start doing anything Docker I want. You will see speed, sometimes 40 Mbps, 70. You wish it's your house internet that is running like that. So that's an example use case. You can be more productive by just provisioning a server. And once I'm done, I can provision like 32 gig. I've done what I want to do. I just delete it by simply removing the resource I've created in the Terraform file, and it will notice that something has changed. Okay, this guy has removed this particular resource. It will now connect to DigitalOcean and delete it. Now, how does it know that? Because it maintains the state of your infrastructure, and it can maintain it either on your host system, that means the system you are using, or if you are working as a team, or for security purpose, you can host the state of your Terraform deployment in the cloud remotely, like on S3. I think one of the major ones that is support, apart from console, is hosting this state on S3. So that means no one can either corrupt or delete the state of your infrastructure. Now, let's see, and Terraform has its own provisioners. Unfortunately, it doesn't have for Ansible currently. Maybe they are working on it. I've seen a couple of issues on GitHub. But you can do a lot of things with these two provisioners that they provide. Local exec, I will show you an example of it, and remote exec. Local exec is where the commands you are running are going to run on your own system. Maybe like you've provisioned the server and you want to, maybe you now use Ansible to do something and you want to get all the IP addresses. You can now execute it under the local exec provisioner, get all the IP addresses, write them to the host, and you can run Ansible against those hosts if you want to use Terraform and Ansible together. Or you can use remote exec. Remote exec, the commands you'll be running are going to run on the instance, not on your local system. But this one has a catch. You can either use username and password or use SSH to run it. Now, let me run a quick demo of running a web server on see this. Now, I have Sorry. Now, this is an example of what digital Terraform configuration looks like. The first one is I've declared a variable to hold my DigitalOcean token. Then I'm maintaining my state on AWS. So I've also created a variable for it and for the access key ID and the secret key. Now, I'm now telling Terraform that I want to use this provider, DigitalOcean, with this token that I've declared here. Now, the next stage is to tell it that I want my backend, where my state will be stored, to be S3. In this bucket, in this file name, using these keys, and it should be in this region. EUS2, that's London. Now, the next thing is...
Sorry. Do you have the same feature for Ansible? It's currently states in S3.
No, Ansible is stateless. Terraform is stateful. Okay. Yeah. Then, after I've declared that, the next thing is I'm adding my SSH key. Look up my public key from my system and create this droplet while attaching these keys. In GitLab, anytime we provision a server, it's not only your SSH key that is added. The keys of people in the production team are also added in case they need to do anything or something is wrong and they need to enter your server. That means the production team, they can also enter your server. You can this is an array. You can specify list of SSH keys. Are we getting it? Now, then the next thing is the resource. I want to deploy a 4 gig RAM instance at the London data center of DigitalOcean, and I need to use private networking. Maybe if you're using something like GCP, where you worry about egress and ingress, it costs you for bandwidth outside some regions or to another different network. So you can enable private networking for communication between the instances, the droplets, so that they are communicating over the local network, not over the internet. And you can enable backup and give it a name. And once it's done, you can probably output the IP address. So let me run simple script. The first thing you do is, I've already specified almost everything I need in my environment. So I can just say Terraform. I have it installed here. Tools, Terraform, init. First thing, I initialize it. Because I have 2 files. You can name them anyhow you want. I have, these 2 files, configs for all of my variables, and I have my droplet here. So as soon as I do init in that folder, any .tf file is passed to read all the configuration or any resources you've specified. Now, it's not usually from your configuration, it will now check, okay, what resource does this guy need? He needs DigitalOcean provider and a Terraform plugin also. Okay, it's done. Now, Ansible, when you're implementing your infrastructure with, you're versioning it with Git, and you want to do testing. Another use case, you have a startup, you want to watch costs or how developers or production team provision servers. You can implement a situation whereby you make if you are using Git, you can make your master protected so that everyone that wants to create an infrastructure will just open his own .tf file. Okay, I need a server with 8 gig RAM, I need this storage and so on and so forth. He creates a pull request. Okay, manager, help me manage it. You can now run, you can use continuous integration to now run Terraform plan. Okay, what does this guy need? His resource, what will it consume? What RAM? You can even specify cost. How much will it cost you per month? Maybe $40 or $50. Then you can set approvers. Maybe the CEO has to approve. If you're using something like GitLab, have to approve the merge request. Okay, he has reviewed it. Accounting department also has to look, then click approve. You can now say, okay, until all these people approve before you can merge the pull request or the merge request. Are we getting it? So you can use Terraform plan. Plan to know this thing this guy wants to do. What changes is he trying to make on the current infrastructure? And what is happening is you see, just like Git, plus he's creating. The first thing he's creating a droplet with this name web. He's using Ubuntu 16.04. Okay, he wants to situate it in London. Maybe you have a policy that, oh, because we are using a particular internet service provider and it's routing through Amsterdam, we want speed. All our instances should be in Amsterdam. And he now make a mistake. You can say, no, Oga, we'll change this region to Amsterdam. Then he's using 4 gig of RAM. Then he's also adding this SSH key. So if everything is okay, you can then say Terraform apply. Oh, sorry, let me do one thing. Because I'm using the same DigitalOcean account, there will be conflict of SSH key. It will tell me the SSH key already exists. So let me remove this. Terraform apply. So now, what it's doing here first is checking the state of your infrastructure. Okay, to connect. Is there anything I need to confirm between the current state and what this guy is trying to apply? Okay, if there's none, then it will start applying. You see, it's creating. That's created the SSH key. It's creating this. It can take some seconds to create. Now, just like what we did with Ansible, you can also deploy HA. This time, DigitalOcean provides load balancer as a feature. You don't need to sorry. Now here, I'm trying to replicate exactly what I did with Ansible earlier. First is to add my key, SSH key. Then the next thing is to create a web server. The first one, web 1. Then I'm using a provisioner here. I want it after creating the droplet, it should execute some commands. Maybe I want it, as soon as it runs, some key things should already be existing on it before I even connect. But you also need to, if it's going to run it, you need to give it access to connect to the server by specifying your private key. And the user is going to log in with. You can either specify maybe you should use SSH or you should log in with username or password. And what should it do? Okay, update my apt cache, install Apache 2, and create this file. Just echo these contents to this file. And you do the same thing for the second instance. All this is online in the Git repository. Then the next thing, now you see here, this particular feature, you can ask it to output how much will this instance cost per month. There's option for per hour and monthly. So that maybe your accounting department can say, guy, go reduce this thing. Then the next thing is to create a load balancer. Make it available in the London region. This is the forwarding rule, the entry point and the target which port, then the health check, and what instances are the backend. What's the IP addresses of the backend? You specify the droplet IDs of the backend. That means you can use variables because I gave each of my droplet names web02 and web01. So here you can use that to reference them by their IDs. And once it's done, you can output the IP of your load balancer. Let's check if, this guy has finished executing. And you see, it published my IP address here, so I can easily access it. Do we have any question on Terraform also?
Yeah, you kept talking about you need to create a key, like in the TFL99.
Yeah.
Which key is this actually?
SSH key that you want to use. You might create a special one for connecting to the server. Let's say you want SSH to the server. Like this now, I can pick this IP address. Because it's my local SSH key, I can say SSH root at.
Sure.
And I'm in. Because it's my default SSH key that I'm using. But you can create a different SSH key for that. Then you have to be specifying SSH-I, then it passes to the key. Any other question?
Does it make sense to actually comment your config file?
Yeah, you can comment. You can use the pound key. That's hashtag. You can comment. You can add comments to. You see, for example, like here.
Okay.
I wrote this. Now, the last thing is running all these things with continuous integration and continuous deployment. Now, you have a system where you need to approve whatever your developers are doing, what resources they are using, and you want to know at what point in time, probably you deployed a party, someone made changes to your infrastructure. You now say, Kai, instead of even investigating, we'll not investigate now. Let's go back to the way the infrastructure was. Because you are using Git, you can revert back to a particular version of your infrastructure and apply that again, and all your infrastructure will be deployed. So you can make use of continuous integration, which is for automated validation. You want to test. For Ansible, you can say Ansible playbook -- check. Instead of that applying the changes you want to run, it does a dry run. Okay, if I'm to execute it, what will happen? Then it will now output all the changes it's going to make. While for Terraform, I did it earlier, Terraform plan. It will now show you, okay, these are all the changes I'm going to make. This is what I'm going to add. This is what I'm going to remove. And then the next one is continuous delivery. You know, continuous delivery is where you are releasing software. You release rapidly, and continuous deployment. Continuous deployment is where I did Terraform apply. Your CEO has approved. Accounting department has approved. Next thing, merge. Your CI, as soon as it's merged, your CI can just deploy it to DigitalOcean without any manual process. So, and there are tools that you can use. All this one. I'm going to demo with GitLab Runner. And this is like a simple process where you write your script, you make a push to Git, then the CI is triggered, continuous integration is triggered. Okay, let me check. Hope this guy has not messed anything up. If he has messed something up, error, it will fail. Then you have to check, okay, I made a mistake here, and push again. Now, if everything is fine, you can actually set a rule that integration Terraform apply, whenever CI is run, it should run Terraform apply on it should run the integration test on any other branch except master. So you have to create your own branch. Someone has to review it before it's merged. Then when it is merged to the master, then it can now execute continuous deployment, where it will run something like Terraform apply, and the infrastructure will be deployed to DigitalOcean. Now, a merge request is created when your test is okay. If there's something you need to correct or there's a review, you make changes. But if everything is fine, it's merged and it's deployed to whichever platform you're using, either AWS, GCP, or DO. You can even now, with the help of Helm charts, you can even manage Kubernetes clusters now using Terraform. Now, Terraform doesn't currently have a provisioner for Ansible. So what you can do is to use local exec or to output IP addresses to a particular file. That will be like your list of hosts that you can now apply your configuration management with Ansible on, or you can run Ansible directly from local exec, whichever you choose to do. Now, before question and answers, let me just show you an example of an integration CI test that can This is an example of a CI script. This is GitLab CI. Now, the first thing it will do is based on Docker. It will pull a Docker container, set all these variables. All these variables, security, you cannot put your, my repository is public. You guys can even see my GitLab CI. If I put my token here now and other things, everyone will see it and can do whatever they want with my account. But instead, I set them as environment variable using secret variables in the GitLab panel. Other CI tools also have how you can set your environment variables. And I have 2 stages, planning and deploy. This is Terraform. And you should run all these scripts first. Echo my private key to this file so that I can use it later. Terraform has a particular feature. If you want it to automatically load environment variables, you specify capital TF underscore capital VR underscore the name of your variable. So when you are calling it from inside Terraform, it automatically recognizes this variable. Now, it should update my cage, install unzip, install wget, run CA certificate, then download Terraform. You should unzip it into this directory, and it should now do init, the init I did earlier. Then, the first stage, I have 2 stages, planning and deploy. The first stage it should do is planning, Terraform plan. And it should run it on any other branch except master. It should not run it on master. It's only after it has been reviewed and it has been merged. That is when your changes enters master now. Abi? Then when you execute this again, it will now run plan and now run Terraform apply, because it's only applied to master. So you can have a system where you can create any instance with Terraform, create the file, then you push. Your manager will review it. Okay, everything is fine, merge, and your instance will just go live almost immediately. The same thing with Ansible. You specify all your variables, you install everything you need, then you execute Ansible playbook, and it will run everything. I didn't add the except master, only master here. I only ran, anytime you run it, it should just, anytime you make a change and you push, it should just deploy the server. Any question, please?
What kind of license do you need to run Terraform and Ansible? Is it a free tool?
Open source. Open source, yeah. I was mentioning Ansible Galaxy the other time. It's a hub for finding and reusing or sharing. Whoa. I don't turn ninja. Now, if you don't want to go to the rigor of, I want to install Apache, PHP, a load balancer, for you to have to create your own rules all over. You can come here and search for rules, and it's as simple as saying Ansible Galaxy install.
Sorry, it should be right.
Okay. Install this rule, and you have lots of rules to Maybe you want to deploy Grafana, you want to deploy Elasticsearch, all of them are here. Or maybe you want to deploy your own VPN. You can just download a VPN role here and just deploy. Everything is already there. You don't have to create your own. Any questions, please?
So aside the Ansible Galaxy, what other
From, I don't understand your question.
aside the Ansible Galaxy?
No, Ansible Galaxy allows you to download roles that people have already created for you to reuse. So you install it and you can deploy. Then aside from that, you can write your own roles, your own playbooks, and execute. For Ansible Galaxy, the command is Ansible-Galaxy. For playbooks, Ansible-playbook. But if you want to run the command, you run playbook because you've already stored your task, the commands you want to run in a file. That's when you run playbook. But if you just want to run a command directly from command line, you just say Ansible, this host, this command. Maybe like a ping, you want to ping the servers or something. Any other question? This slide is shared online, bit.ly/do, it's coming up, here, DO Lagos 17-Ango. So you can access the slide. The links to each of the examples I demonstrated are on Git, it's also on the slide. The answers of any question, thank you very much.